All right, let's jump right in. We're about to tackle one of the biggest, most mind-bending mysteries right in our own backyard, cosmically speaking. You see, the sun is hot, we all know that, but it's hiding a secret that seems to fly in the face of basic physics. And today, we're diving into a source that puts forward a wild new theory to explain it all. So here it is, the big paradox. The surface of the sun, the part we see, clocks in at about 6,000 Kelvin. Hot, for sure. But here's the crazy part. As you move away from the surface, out into its atmosphere, the corona, the temperature doesn't go down. It goes up, way up. I mean, how is that even possible? It's like stepping away from a campfire and getting warmer instead of colder. It makes absolutely no sense. And we're not talking a little bit warmer. The corona can hit an insane 20 million Kelvin. To put that in perspective, that's as hot or maybe even hotter than the sun's own core. So the question is, what in the universe could possibly be superheating the sun's atmosphere like this? Okay, so what's the official explanation? Well, mainstream physics has a leading suspect for this mystery, a process known as magnetic reconnection. Now, the textbook definition sounds pretty dense, I know, but the basic idea is that you have these different magnetic zones inside a plasma, and they can kind of swap their magnetic field lines, and when they do, boom, a massive burst of energy gets released. So picture this. You've got these magnetic field lines flowing in opposite directions. They slam into each other, they break, and then they snap back together. They reconnect in a totally new arrangement. And this whole violent reshuffling is what's supposed to shoot out particles and convert all that stored magnetic energy into the crazy heat we see in the corona. But, and this is a huge but, here's where things start to get a little shaky. Even the people who champion this theory will tell you there are some major gaps. This quote here says it all. When this process actually happens, it moves way, way faster than any of their models can explain. This is the first real crack in the official story. And that brings us right to the heart of our explainer today. The author of the source we're looking at says these aren't just little gaps in the theory, they're fundamental, deal-breaking flaws. So let's get into that critique. The author basically hits the pause button and says, hold on, we're using all these terms like field lines and domains and exchanging, but what do they physically mean? What is a field line really? What's actually being swapped when they exchange? According to the author, the theory just kind of glosses over these super basic mechanical questions. And the critique doesn't stop there. It goes after the two big historical models for reconnection. You've got the Sweet-Parker model, which is just too slow. It can't explain the speed of what we actually see. Then there's the Petschek model, which only works in computer simulations if you plug in unrealistic numbers, like inventing a huge amount of electrical resistance in the near vacuum of space. The author's take? These models are basically dead ends. But this is what the author presents as the final nail in the coffin. See, every single model of magnetic reconnection needs at least two different plasmas with opposing magnetic fields to collide with each other. But the sun, it's just one object. It's emitting one plasma, the solar wind, which flows outward. So where is this second plasma that's supposed to be meeting it head-on? The author's point is simple. The basic setup that the theory demands just isn't there. Okay, so if the mainstream theory has all these problems, what's the alternative? Well, our source doesn't just poke holes in things. They propose a completely different idea, and it's all based on a new fundamental concept they call the charge field. This right here is the core idea. The author claims that for centuries, physics has been mixing up two totally different fields. We all know about the electromagnetic field. It's made of charged particles, ions like electrons and protons. But the author says there's a deeper, more fundamental charge field that's made of photons, light particles. And they claim this photon field is the real engine driving everything, and we've just been completely overlooking it. So, based on this idea, the author lays out a whole new mechanical process. It works like this. Any spinning object, like our sun, is sitting in a background field of photons. As it spins, it sucks these photons in at its poles and then spits them out at its equator. Now, this field of photons being ejected from the equator runs head-on into the background field that's already there. In those collisions, the spins of the photons cancel each other out, and that releases their stored energy as pure heat. This, the author argues, is what's really heating the corona. Now, that's a cool story, but a theory is only as good as its predictions, right? Can it be tested? Well, the author tries to do just that by linking the heat of the sun's corona to something else that's been a bit of a mystery, the weird brightness of planets in the outer solar system. So let's walk through the math here. The author takes Uranus's upper atmosphere temperature, about 850 Kelvin, which they say is also caused by this charge recycling thing. Then they calculate what they call a charge differential between Uranus and the Sun, which is based on their mass and spin. That number comes out to be 25,400. So you take 850 Kelvin, multiply it by 25,400, and you get 21.6 million Kelvin. That is shockingly close to the actual measured temperature of the Sun's corona. Okay, but wait. If it's the exact same process happening at the Sun and at Uranus, why does the energy look so different? The corona's energy peaks in the infrared spectrum, which is invisible to us. But the energy from Uranus that the author is using for the calculation peaks in visible light. How does the theory explain that? The author's answer comes down to another new concept they introduce called field imbalance. It's all about the ratio of regular photons to what they call antiphotons, basically particles with the opposite spin. To get the biggest bang for your buck in a collision, the most energy release, you need a perfect 50-50 split between the two. And here's how it plays out. According to the author, the Sun's powerful spin creates a really imbalanced field. There just aren't many antiphotons close by. That means each collision is kind of weak, releasing lower energy infrared light. But way out at Uranus, the background field is much more balanced. So each photon collision is way more powerful, releasing higher energy, higher frequency visible light. So let's be super clear on this because it's the key point. The author is separating two different things. The corona's incredibly high temperature comes from the sheer quantity of collisions. There are just billions and billions of them happening. But the lower frequency of its light comes from the lower quality of each individual collision. More collisions, but less energy per collision. So let's just wrap up the big ideas here. We've looked at a source that takes on the mainstream explanation for the Sun's impossible heat, arguing it's built on a shaky foundation. In its place, it offers a radical new idea, a hidden charge field made of photons. And this new theory tries to tie together the heat of our Sun with the strange glow of distant planets, all with a single, elegant mechanism. It's a really provocative theory, for sure. And it leaves us with one last big question to chew on. What if the solutions to the universe's greatest puzzles don't require us to find exotic new dark matter or dark energy, but just require us to look at the most common thing in the cosmos, light itself, in a completely new way?